Hello friends, today let us discuss about electronic engine management system. So we are going to discuss today electronic engine management system. Now what is this in electronic engine management? We know that there are many parameters which need to be controlled in engine to ensure that operation of the engine is being done properly. But if these parameters are to be controlled manually, then the manual systems give some problems like problems related to inertia, problems related to when different parameters change their values and so on. And therefore nowadays electronics management or electronic control is more preferred over mechanical control even in automobiles, and therefore electronic controls has become a trend in case of automobiles. And nowadays you can see that there are so many electronic controls used in automobile. For example, you need to control parameters like related to fuel supply, you need to control parameters related to pollution, or you need to control parameters related to ignition. Whenever you want to control all these parameters, nowadays it is preferred to use electronics over mechanical, because electronics are more handy, they are easy to control when compared to that of mechanical, which are bulky and are difficult to control. And therefore moreover, one more thing has to be taken into consideration, that this electronic controls are a bit costlier, but obviously when manufactured in bulk, the price is going to reduce. So all those things are going to has to be taken into consideration for electronic engine management. Now let us discuss what this electronic engine management consists of. So it consists basically, electronic engine management consists of system consists of 1. Sensors. 2. We have signal conditioners. 3rd, we have analog to digital converters. 4th, electronic control module. 5th, we have output signals of different types. 6th, then we have drives, and we have actuators. So basically an electronic engine management system consists of these many things. Now with the help of these things, we are supposed to control certain parameters, and out of this different components, the most important is the electronic control module, because it becomes the heart for controlling this particular parameter. And what is consist of? Basically, electronic unit is a unit which has a program inbuilt in it, and with the help of this particular program and with the help of some input given to it, it processes the data which it receives in the form of input sensors from the input sensors, and produce some signals related to actuators which help in governing the thing what we want to control. So that is how it is actually works. So the heart of this particular system is ECU. So if you with the help of a block diagram, if you want to understand it, this is your electronic control unit, or what we call as ECU, and here we have different sensors. So different sensors and this ECU will actuate some actuators. So we have some actuators. So this is how it generally works. Now, in order to understand how it works, let us first discuss what are the different sensors and what are the different actuators, for example. So, for example, the different sensors what are used are maybe crankshaft position sensor, we have camshaft position sensor, then we have coolant temperature sensor, then we have engine speed sensor, then we have airflow sensor, then we have exhaust oxygen sensor, then we have EGR wall position sensor, that is exhaust gas recirculation wall position sensor, then we have exhaust manifold pressure sensor, we have inlet manifold pressure sensor, we have inlet manifold temperature sensor, we have oil temperature sensor and pressure sensor. So like this, so many sensors are there in an automobile which need to be need to be sensed in order to, so all this particular, like this there are so many sensors, and all this particular senses some parameter, and this particular data is given to a corresponding ECU. And what ECU does is, on the basis of this particular data, what it has received in the form of this signals from this ECU, it is going to process that particular data, because it has some inbuilt program in it, and with the help of this program and the data, it is going to process this particular data, and it will give signals to the actuators to actuate. Now, what are the different actuators? For example, we have so many actuators like injection timing, we have injection quantity, we have ignition timing, we have wall timing, we have coolant flow rate, we have emissions. So all this particular controls are there. Like this, there are so many actuators, and all these particular actuators are helping to control certain parameters so as to get the desired output from the system. So this is a outline of a ECU, how it electronic engine management system, how it works. So basically what it does, we have so many sensors, associated sensors. The ECU will take the data from this particular sensors, it processes the data, and to find out the values of signals which are supposed to be given to the actuators in order to control this particular parameter. So that is how it works. So this is a basics of a electronic engine management system. Now let us understand this on the basis of taking one particular control, one particular parameter which need to be controlled. So we have now suppose we have electronic fuel system. Electronic fuel supply system. So now we have electronic fuel supply system. Now here what we need to control in order to with the help of electronic fuel system. So basically the parameters which need to be controlled are the injection timing, that is at what timing we are going to inject the fuel. We have injection rate, that is how much fuel is going to come out of the injector at a particular timing. We have the frequency of injection, that means which depends on the engine speed. That is, if this engine speed is more, then we want more frequency. Then the mass of injection or injection quantity. So these are the parameters which need to be controlled, and this will be controlled with the help of actuators. So different actuators will help in controlling this particular parameter. Different actuators work to control these parameters. And when we control this particular parameters, we get the desired output. So the output in terms of fuel economy. So the output expected from this particular system is fuel economy, less emissions, we have knock-free operation, etc. So like this, we want so many parameters output from this, and in order to achieve this particular things, we have to control these many actuators. So the signals required for this particular actuators, that will be provided by ECU. And what are the sensors required for this? So the different sensors which will be requiring for this particular system to work are engine speed, intake air temperature and pressure, intake air quantity, lubricating oil temperature, crankshaft position sensor, supercharger, pressure, load on the engine, etc. So many sensors will be required, and all this particular data when given to ECU, so the ECU will process this particular data and accordingly give signal to actuators. And what actuators are going to do? The different actuators are there related to injection timing, injection rate, frequency of injection, injection quantity. Then we have the supercharger. Then we have the speed sensor. Speed is as a parameter. So many parameters are there. So all these particular actuators will be given signal to operate in a certain manner, so that these particular parameters are going to be controlled, and accordingly we will get a fuel economy, less emissions, free knock free operation, and so on. So this is how electronic system, fuel system works. Similarly, when you talk of any other system, it will be working in a similar manner. Basically, that means it will have a ECU. So the number or the parameters which we want to control, accordingly that many number of ECU will be required, because ECU will giving signal to different actuators, and ECU will be there. That ECU will require some data, and ECU will give signal to some actuators, and with the help of the actuators the required parameters will be controlled in order to get a particular output. For example, we will take another system. For example, we will take electronic pollution control. So when we talk of electronic pollution control, so in order to this particular work as a electronic pollution control, what all things we need to control? We need to control different pollutants like sulfur oxides, nitrogen oxides, unburned hydrocarbon. Then we have smoke, carbon monoxide, particulate matter, noise. So these particular parameters we want to control. So in order to control this, we will be having something like catalytic converter, total emission packages. So we have so many things, that is catalytic converter, thermal converter. So all these systems we are having. We have total emission package control system, like this, etc. So like this, so many systems will be there, and these particular system we want to control, and for this we will be requiring so many sensors. So some of the sensors what are required, so that is in terms of input whatever we require. So here we will be using some sensors. So the input sensors required are related to fuel injection, that is what is the present fuel injection going on, what is the injection timing presently, we have what is the injection pressure presently, what is the injection rate, then what is the amount of EGR present going on, then what is the intake pressure, intake air pressure, temperature, oblique mass or quantity. Then we have wall timing. We have camshaft and crankshaft position sensors. So like this, so many parameters need to be controlled. So when we all these particular signals, when we get the system is now, ECU is now coming to know that this particular, that is, for example, this is what is the present intake air pressure, what is the present inlet temperature, what is the mass of or quantity of air inhaled by this engine presently. Wall is the, what is the value of wall timing, at a particular instant, where is the camshaft, what is the position of the camshaft, what is the position of the crankshaft, how much fuel is injected, what is the timing of injection, what is the pressure of injection, what is the rate of injection. When all these particular things are known, then accordingly the system will control with the help of actuators. With the help of actuators, wall timing, that is, we have something called as a variable wall timing system. So this will be controlled. Then we have evaporative loss control device. We have charcoal canister, wall. Then we have EGR wall. Then we have positive crankcase ventilation wall. Then we have fuel injection related parameters like fuel injection timing, fuel injection pressure, fuel injection rate. So all this actuators has to work together. So when all these things work properly, then so that means what is happening? We have some data we are getting from this particular sensors. All this data will come to ECU. ECU has a fed program. With the help of this particular data, the program is being run and some output values are produced, which is given to different actuators, like how much wall timing has to be changed whenever the evaporative wall control device is going to be actuated. Charcoal canister wall is supposed to be closed or open. EGR wall, to how much it is closed, how much it is open. Positive crankcase ventilation wall is supposed to be operated. Fuel injection related parameters like injection timing, the injection pressure, injection rate, injection quantity, all these are going to be so related, like quantity, timing, rate, etc. are controlled. So this is how electronic system works. So basically what we have understood from today's lecture is summarizing. Basically there are so many parameters which need to be controlled with related to engine. When we want to operate the engine in a proper manner, for example, we want to go for decreasing the emissions, or we want to increase the fuel efficiency or mileage, like that. Whenever a certain parameter is need to be controlled, we have some electronic systems used nowadays. Unlike earlier, we used all mechanical systems. For example, we had governors to change the fuel earlier. Now, in order to change the fuel with the help of governor, the governor has to operate it, which is a mechanical system where there is certain mass coming into picture, and when there is a mass, there is a inertia, and the problem related to inertia will be there. But if you want to overcome this, therefore the response of the governor will be limited depending on the type and size, etc. And to overcome the problem related to the mechanical system, nowadays we prefer to use electronic systems. That means with the help of these electronic systems, we will be able to control the parameters more properly, accurately. The response will be faster, and therefore the efficiency of operations will be better. And for this, what we have is ECU. So basically a ECU is a unit which takes some data from the sensors. It processes the data and controls some parameters. So different sensors will be required according to the system what we want to control, and what are the parameters which we want to control. Accordingly, we will require different sensors. There are hundreds of sensors in automobiles nowadays, and all this particular data coming from the sensors is given to a particular ECU corresponding to which parameter we want to control. So this particular data, when the is coming to the ECU processes this particular data and finalizes the value of the signals which is given to the actuators, and accordingly the actuators will come into action and control that particular parameter. For example, if you want to control the fuel system, then you are going to control the injection timing, you are going to control the rate of injection, you are going to control the frequency of injection, and you are also going to control the injection quantity. So when all these particular things are controlled, your injection is going to proper, which is going to ensure that the combustion is going to be proper and the emission is going to be less, the fuel efficiency is going to be better. Like this results we will get. So that is how electronic system work, and it can be related to variable wall timing. So for example, if you talk of a wall timing, with the help of a variable wall timing, the pollution related and the fuel related actuators has to be operated, and in order to operate this, when we actuate this particular actuators, we will get a proper torque, we will get a proper output, the battery and fuel efficiency will be increasing, we can reduce the emissions from the engines, etc. And the sensors or the value of the sensors, different sensors required for the variable wall timing will be the crankshaft timing, present position of the variable wall timing shaft, that is the crankshaft or camshaft position sensors, then the coolant oil wall, then the throttle position wall sensor, mass of the air sensor, engine speed. When all this particular data is given to ECU, the ECU will process this particular data, and accordingly it will give the signal to the actuators to control the actuator, and the actuator is now going to actuate and control the parameter which is supposed to be controlled, in order to ensure that wall timing is going to be proper according to the requirement, because we know that as the speed changes, the wall timing has to change, and when this is happening, then we'll get proper output. So in order to get proper results from the engine, that is operation efficiency from the engine related to different parameters, nowadays we have so many electronic systems, and electronics, this particular system is what we call as engine electronic management system. Thank you.